This shape is a rhombus, which means that these lengths, okay, the sides of the rhombus, because the rhombus is just a square, are all going to be exactly the same. And I can see, therefore, that because the diagonals are split 6, 6 and 4, 4, one of the properties of rhombus, each of these triangles is identical. So the easiest way to find the area of the rhombus is to work out the area of one of these triangles and then multiply by 4. So if we look at this triangle, I can see that the base is 6 centimeters and the height is 4 centimeters. Remember, the area of a triangle is just half base times height. Okay, the height and the base must be perpendicular to each other, right angles to each other, which they are. So this is my base, 6. This is my height, 4. And the area then is just going to be 6 times 4, which is 24, halved, which is 12 square centimeters, which means that the area of the whole rhombus is going to be 4 multiplied by 12, which is 48 centimeters squared. Second part of the question here asks me to find the length of AB. And again, I'm going to use just one triangle here to make my life a little bit easier. So this, I'm just going to draw it again. This is triangle BEA. This is the length that we're trying to find. I know that this is 4 centimeters and this is 6 centimeters. So it just becomes a Pythagoras question. So I'm trying to find the length of the hypotenuse. So I know that the hypotenuse, which is this length here, the hypotenuse squared is equal to the sum of the squares on the other two sides. In other words, this short side squared plus this short side squared, which is just 6 squared. In other words, I'm going to do 16 plus 36, which comes out as 52. So the hypotenuse squared is 52. So that hypotenuse, in other words, AB, is going to be the square root of 52. If I work that out on my calculator, I get 7.21110, etc. I'm going to round it to 3 significant figures, as the question says, so 7.21 centimeters squared.